Hello everyone, welcome to another session for optimization techniques. Today we are going to first briefly introduce myself, then we will continue to talk about the basic concept of design of experiments. As you know, my name is Farda Jelian Tabar. I'm senior lecturer of UMP College of Engineering. You can find more information about me on my in my YouTube channel or my Google website. Okay, so let's go to the our subject. Uh, this session is related to the course learning outcome number 1, which is about design of experiments for engineers. We will summarize the optimization results in various engineering problems using the design of experiments, which whole this yellow will include and it will start actually by an introduction to design of experiment. Then we will talk about the history of design of experiments. We will talk about principles and terminology for this design of experiments. In part 4, we will talk about strategies of experimentation. We will introduce different methods for design of experiment, and in part 5 we will I will introduce you some guidelines for planning and conducting of the different experiments. In part 7 we will start to more go to details related to the uh, uh, different type of the design of experiment which we have. We will talk about a screening method in part 7 and part 8. In part 9 and 10 we will talk about factorial design. Part 9, 10 and 11 we'll talk about the factorial design. Later you will see what is this type of design. In part 12 until part 14 we will talk about Taguchi method, which is another method for design of experiment which can be used also to optimize different processes or systems. Let's start with an introduction to design of experiment. Why generally we need to have design of experiment? As an engineer, you may know that usually we are interested to see what will be the effect of different factors to some variables or some responses. Actually, we can call them like this. To do this, we can have different methods, but the scientific procedure is to start with planning of a design of experiment. So to understand and learn about how a system or a process the how this system or process works, we usually need to observe it. This observation usually need to understand the cause and effect relationship in a system. And to understand these cause and effect relationships, actually, we need to conduct experiments, as I told you, on that system or process. Observation on system or process can lead to, after this observation and after this experimentation, we may come out with some theories or hypotheses. But these theories and hypotheses can be only approved using different experiments, and these experiments are required to demonstrate these theories, which they are correct or incorrect, or even they are rejected or approved. Some of this, this procedure actually can be used in different area. A simple example is like cooking fried rice. It seems to be easy to prepare fried rice. However, sometimes it may not be that much easy. But you may have some idea about what are the effective factors, how you can prepare a good fried rice. You may think about how much rice do you need, how much water, for example, if you need, what should be temperature to cook this fried rice, what should be the uh, time or duration for cooking and preparing this fried rice. All of these are factors. You need to decide about that. Even the size of the pots or pan, it is another factor. You need to decide about that before you start to cook or your fried rice. And each one of these factors can be justified. In other words, the temperature is effective. So, too high temperature, too low temperature may not be appropriate for cooking fried rice. So you need to optimize it. You need to find the appropriate temperature to have a good fried rice. This is what we call it optimization. And the one procedure to find and optimize the, for example, temperature for cooking of this fried rice is using up design of experiment and different methods, which I will introduce you after. The other example, simple example, is when you are going to make a paper aeroplane. Again, you need to know what should be the size, of a different part for this paper aeroplane, and how you, the paper which you choose, the size, and everything related to a paper aeroplane, which you can have a better design to have a paper aeroplane with better performance. I don't know, the longer distance it can travel or it lasts longer. So to prepare even a simple object like a paper aeroplane, again, you may need to have a design of experiment. You may think, okay, if I use this kind of paper, it will travel, it will can fly longer, but you need to prove it. So you need to use that paper to prepare the aeroplane, paper aeroplane. This is just few simple examples about what is actually design of experiment. As you can see here, it can be used in a different field, not only engineering. However, the more interesting result can be seen when you use this design of experiments in engineering processes or systems. To have an appropriate design of experiment or DOE, you need to understand what are the effective parameters, what are the effective factors actually on your results. In other words, if you remember, for the cooking of fried rice, I talked about the temperature of the which you can use. So it is one of the effective parameters. You can guess and you can choose it as one factor. So we need to determine which input variable are responsible for the observed changes in the response. These input variables which are responsible, which we choose actually, are factors, and we call them independent variables. After this, we will discuss about them more. And what will be the result will be our responses, like the quality of the fried rice. If you can have a table to score the quality of the fried rice, that can be a response for our experiment. So to find this relationship between input and output, we need to have a model relating these responses to important input variables and use this model for process or system improvement or even other decision making. This is another application, another advantage of using DOE. You can improve a system or a process, or even you can have a better make a better decision about that system. The other reason why DO is important is actually experimentation plays an important role in technology commercialization and product realization activity. For example, you design a new equipment, but you don't know if that equipment fits all of the customer or user. So you can design an experiment to see if the people from different by different variety of people how will respond to this new technology. For example, mobile phone. Which size of mobile phone may be more interesting for people? So you can prepare a questionnaire and ask them about the favorable design, the size of the mobile phone. So this kind of the method to understand the people desire about it. This new technology is called also a type of design of experiment. And also design of experiment is a key for innovation. In other words, when you have something in your mind, any innovation, you need to check it. You need to understand if these new things or novel things it may be useful for society. Then you can design an experiment and check if it is useful or even if it works or not. This can be done by design of experiment. For example, a new vaccine for COVID-19. You need to design of an experiment to check if it works or not, or how will be the side effects of that. So this can only be done by design of experiments. And sometimes we need to have experiments even for some of the scientific principle, which you may already know about that, or scientific phenomena you may know about that, but you need to have some mathematical model for that. Then by this mathematical model you can better understand that scientific phenomena. For example, the relationship between the elevation and boiling temperature of the water. This one, it is a phenomenon, and you can find the equation for that. Or another simple example is spring rain. You know about that. We have a relationship between the force, which a spring force actually, and the distance, which you can compress it or extend it. And this relationship can be defined like this: F equal to Kx, which Kx is the spring coefficient. And another example is Ohm's law. Both of these two laws, or both of these two models actually, have been found by design of the experiments. Different type of the springs have been used, and then they have been compressed or extended. Then they found a relationship between the force, distance, and they call that K as the spring constant. And same for Ohm's law, which is a relationship between the potential, the current, and the resistance of the medium which we have electricity inside that. So both of these two models have been proposed using design of the experiments. So this is another one of other application or advantage of design of experiment, to find this mathematical model actually. These two models seems to be easy even, and nowadays we have more complicated models because usually our systems Our processes includes more than just one or two factors. For example, here we have one relationship between f and x, which by this constant we can find it or write it. It is just a linear relationship. Sometimes it is not that much easy and we need to more complicated equations. And so by this we can also conclude that most problems require observation of the system at work and experimentation to elucidate information about why and how it works. So this one also uh, can be elucidated or determined by design of experiment to understand why we have failure in a gear, why we have failure in a shaft, why our air conditioner we have failure in air conditioner. So you can have a design of experiment to understand the reasons behind this. And based on this introduction, we can say the experiments or DOE are used widely in engineering work for these four main purposes: to process characterization and optimization, to improve the quality of our products, to make a process faster, to use lower amount of the materials. All of them can be used by design of experiments which are related to the process characterization and optimization. The other application is evaluation of material properties. For example, you can come out with a new material, new combination of the different materials to have uh, more strong material. Like when you are trying to find a strong material for a bridge, then you need to choose a steel, a kind of steel for that. The process to determine the appropriate material for this purpose can be done also by design of experiment. The other application is when you are going to design a product or develop a current product and improve it. In that case also we can use design of experiment. You can have different designs, but you need to follow scientific procedure to approve that your design is the best design. So this can be done by design of experiments. And the other application is to determine the component and system tolerance. This one also can be done by design of experiment. We have different examples to show this by different methods. So these are four main application of the experiment or design of experiment in engineering world. Very important part in our introduction. And generally, we can say that all experiments are designed experiments. Even if you don't have any, if you don't think about that, or you haven't already decided about your design of experiment. When you are going to run an experiment, for sure you will follow something. And so for any experiment, we will have a design of experiment. Even if it is not a scientific design of experiment, but we can say that we have only poorly designed and well designed experiments. Remember, just let's go back to our example, cooking fried rice. For sure, finally you can come out, any one of you can come out with a fried rice, or you can prepare a fried rice, but only the difference between the different fried rice which are prepared by you is the quality of the fried rice. So if you follow an appropriate design of experiment, you may have better outcome, better outputs. But if you do not have well-designed experiments or well DOE, then your results will not be satisfactory. So we have always design of experiments. Sometimes it is well designed, sometimes it is poorly designed of experiments. An example of experiment is here, which we can go to the further details related to the design of the experiments. Imagine we have a metallurgical engineer. He or she is interested in studying the effect of two different hardening processes. If you know about metallurgy engineering, you know that hardening is a process which we use usually in this field of study. These two methods are oil quenching and saltwater quenching on an aluminum alloy. Here the objective of experimenter, the engineer which we have here, we call that experimenter, is to determine which quenching solution produces the maximum hardness for this particular alloy. This example may be fits for your current job as well. As you can see here, we have a situation. The engineer should decide which method should be used for the purpose, for this hardening purpose. The engineer decides to subject a number of alloy specimens or test coupons to each quenching medium and measure the hardness of the specimens after quenching. The average hardness of the specimens treated in each quenching solution will be used to determine which solution is the best. So our engineer has started to use a design of the experiments. This design of experiment can be used to distinguish the differences between these two methods for the purpose which the engineer has here. So, what our engineer should consider, or what are the concerns here for our engineer to design the experiments for both of these two methods for quenching? Here are some questions which the engineer should answer before start the experiments. First, are these two solutions the only quenching media of potential interest? This is one of the biggest problems usually we have. Usually we ignore other options. You need to think if you have only these two options, or you may have other options to make this process easier or to have better outcome. So this is the first decision should be taken by the our engineer here. Do we have limited to these two methods, or we can have other methods better than these two, or at least we can have other methods to be included in our study, in our experiments here? The second question is, are there any other factors that might affect hardness that should be investigated or controlled in this experiment, such as temperature of the quenching media? So here, if you notice, our engineer decide different specimen and do the quenching by these two methods. So no information about the temperature. So about the temperature, weather condition, about the other factors which may be effective here. So we need to design our experiment, we need to decide what are the effective factors and our results. So our outcome will be quenching the hardness of our specimen. These factors should be decided before running any experiments. For example, here the temperature is one of those factors which may be effective, or the weather condition, or other factor which can be controlled by ourselves and it is effective on our results. This one also should be decided. The other thing is how many specimens or coupons of values should be tested in each quenching solution. For example, if we just, here we have two different methods. Imagine we don't have any other factors like temperature in our uh, selection process actually here, or decision making process here. Then how many specimens we need to test? If we just test one specimen with oil quenching and one specimen with salt water quenching, then it will be enough. Or two specimens, it will be enough. How many specimens is enough to understand the hardness of the specimens is different between these two type of the uh, hardening. So number of the samples actually here, the number of specimens here can be called number of samples for each factor, for each effective parameter also is another question. We need to decide about that. How many is enough? This is another thing which we do usually in design of experiment. We have a scientific procedure here again, and we can determine the appropriate number of the samples which are required to find the answer for our question. Which one of these quenching processes is more desirable or has better outcome? The other question is, how should the test coupons be assigned to the quenching solution? And in what order should the data be collected? This also is another question. All of this you will see. Answer all of these questions will be the procedure which we do, or the procedure which we take to find the answer for a scientific phenomena, for example, here. So how these samples need to be assigned to quenching solutions, or in what order these specimens, for example, is it appropriate, is it okay if we just do the hardening with one method, then we do the hardening with the other methods and compare them, or it is better we do hardening for one sample by this method one, and do the hardening by second method, uh, uh, and again go back to second sample for hardening by method one, then again sample two for hardening by method two. Which type of this procedure is okay? Going like this, one, then two, or like this, first this, like this. Which one is better? Or random one? Okay, you will see about this, how is the best way to do the experiments. The question number 5, what method of data analysis should be used? Data analysis, design of experiments initially start with some decisions. We don't have mathematics here, not too much mathematics here actually. But after we find our results, we need to evaluate or analyze our data or findings. What method should be used to analyze these findings or this info which we have? For example, we do the quenching, the hardening process actually by these two methods. Finally, we will have hardnesses for all of the specimens which we have, or samples which we have. How we can compare them? How we can say this one is better than this one? For example, if the hardness here is just 100, for example, this is just a number, the other one is 101. Is this difference significant? Can we say the specimens or the sample with 101 hardness is better than the other one? This kind of the comparison can be done only by choosing an appropriate method of data analysis. You will see after this what are different methods for analyzing of our data and how we can use them. The other question should be answered here is what difference in average observed hardness between the two quenching media will be considered important. In other words, after we run the experiment, here, for example, imagine we have three samples here, three samples here. So we will have an average here, average value here for hardness, average value for hardness here also. Then we need to compare these two averages. For sure, there will be usually actually we will have a difference between these two averages, but this difference is important or it can be neglected. This is another question which should be answered for your results. This part also is included when you decide about design of experiments. Why, as you can see here, especially part 5, part 6 are related to after you collect your data. But design of experiments, as it can be seen from its name, is before you run your experiments. So why we should also decide about the after collecting of data when we are choosing our design of experiment, because these are together. When you decide about your design of experiment, how many samples, what should be factors, what should be responses, then it will be effective on the method which you can use for data analysis. For example, if you select factorial design of experiment, which is one of the design of experiment, then you can have just a limited type of the data analysis. So the method the design of experiment which you select will determine the after data collection processing as well. So when you need to think about that also, what are the results which you are interested about, then you can also define or determine an appropriate design of experiment. So the results also are important and you need to take them into account when you are choosing your design of experiment. Totally, why a design of experiment should be used. This is our last slide for today's session. Design of experiment can reduce time to design and develop new product and processes. However, you may need some time to decide about design of experiment to design actually of your experiment, but finally the process of the development or design of these product and processes will be lower when compared to when you don't have any design of experiment. This is something this comes from the experience actually, and it's a result of various studies. And also, design of experiment can improve performance of existing processes. About it, we will have also example in future sessions. Moreover, because here we follow a scientific procedure, and this scientific procedure is already approved by different researchers, we can say that by design of experiment, we can improve the reliability and performance of our products. In other words, our results will be more reliable. And also, we can achieve product and process robustness. We can have more the products and process with higher robustness compared when you don't have any design of experiments. Later you will see also examples about this. And finally, this one, the last one, is what usually we use in science, is for research and development, or in our lab. We evaluate different materials, design alternatives, setting component and system tolerance, and so on. So evaluation is one of the main purposes of the using of design of experiments. So DOE is highly related to the evaluation of processes, systems, materials, and so on. If we want to show design the effective or the component of the design of an experiment, we can show the schematic diagram. Imagine we have a process. This process has its inputs and outputs, and we can have some control factors. These control factors can be like temperature, which we can set, or like humidity and so on, which you can set, you can justify by yourself. They are called control factors, and there may be some uncontrollable factors, similar like when you have experiments outside. Then imagine you are working on solar panels. Then the if you run your experiment outdoor actually, then temperature, the light, the humidity is not under your control. In that case, we call them uncontrollable factors. And what we are going to understand actually is to find the relationship between our output and our controllable factors for different outputs. And this is the main purpose of design of experiment, as to find this relationship, to come out with a model, and finally to optimize, to decide which temperature is best to have a better fried rice, for example. So by this we reach end of this session. In next session we will discuss more about history of the design of experiments. Thank you so much and see you next session.